Hey, what is up? Ace out here from Instaproofs. And for those of you who are currently in algebra, all too often you come across problems such as x minus 3 times x plus 4, a minus c squared, x squared plus 5 times x minus 2, or even x cubed plus y cubed times x cubed minus y cubed, and so on and so forth. And you are asked to expand all these expressions. But how do you expand them? Now, before I introduce you to the method behind expanding them, let me tell you what all these expressions have in common. So before you even attempt to expand, you at least know when to. So all these terms are the product of two binomials, where a binomial is just simply a polynomial with two terms where neither of the terms are like terms. For example, in x minus 3 times x plus 4, in the first binomial, x minus 3, x and negative 3 are not like terms, and in the second binomial, x plus 4, x and positive 4 aren't like terms. And similarly, in x squared plus 5 times x minus 2, in the first binomial, x squared and 5 aren't like terms. Well, in the second binomial, x and negative 2 aren't like terms. You should be able to get the idea. And the way you expand these particular type of problems into a polynomial of multiple terms is a method called foiling. And this will be the topic of this video. So given an expression f of the form a plus b times c plus d, where a plus b and c plus d are two respective binomials, we want to derive a method that expands the expression f. In other words, we want to derive the method of foiling. So we start out with our expression. And from here, we realize that if you let the binomial a plus b equal a constant k, we can use the law of distribution shown above of a times c plus d equal to ac plus ad, and get the following: kc plus kd. And plugging back in for k, we get a plus b times c plus a plus b times d. And using the law of distribution again, and distributing c into a plus b, we get ac plus bc. And using the law of distribution one more time, and distributing d into a plus b, we get ad plus bd. And if you switch the terms ad and bc, you realize that the product ac is just the product of the first terms of each binomial, a and c. And the product ad is just the product of the outermost terms in our expression, a and d. And the product bc is the product of the innermost terms in our expression, bc. And the product bd is the product of the last terms in each binomial, b and d. And by labeling each term as such, AC as first, AD as outer, BC as inner, and BD as last, we get our acronym of FOIL. And by using this acronym of FOIL, we will be able to solve all these problems involving the product of two binomials. So let's do an example. So let's do x plus 3 times x plus 9. Multiplying the first terms, x and x, we get x squared as our first term. Multiplying the outermost terms, x and 9, we get 9x for our outer term. And multiplying the innermost terms, 3 and x, we get 3x for our innermost terms. And lastly, multiplying our last terms of each binomial, 3 and 9, we get 27. And there our acronym appears: first, outer, inner, last, x squared plus 9x plus 3x plus 27. Combine the like terms 9x and 3x, and we get our simplified answer of x squared plus 12x plus 27. Now let's do a slightly less apparent problem, such as 3x minus 9 times 2 plus 3y. Now here, we first multiply the first terms of each binomial, 3x and 2, so we get 6x for our f. Then we multiply the outermost term of the whole expression, so we get the product of 3x times 3y, which is 9xy. And that is our O. And then we multiply the innermost terms of our whole expression, negative 9 and 2, and we get negative 18 for our I. And then lastly, we'll multiply our last terms of each binomial. So we multiply negative 9 and 3y, and we get negative 27y for our last term, or for our L. And here you can recognize that none of the terms are like terms, so we can leave the answer as is. And for our next example, we have x cubed plus 6x times 9 minus 3x. And first, we multiply the first terms in each binomial, x cubed and 9, and we get 9x cubed for f. Then we multiply the outermost terms of our whole expression, x cubed and negative 3x, and we get negative 3x to the fourth for O. Next, we multiply the innermost terms of our whole expression, 6x and 9, and we get 54x for I. Lastly, we multiply the last terms in each binomial, 6x and negative 3x, and so we get negative 18x squared for L. And now, for neatness purposes, we will rearrange all the terms from highest degree to lowest. So for our answer, we write negative 3x to the fourth plus 9x cubed minus 18x squared plus 54x. And for our last example, we are going to derive the expansion of x plus h to the square, because x plus h to the square comes up a lot in the study of math. So we know that x plus h squared is simply x plus h times x plus h. And our first terms in each binomial are x and x, so we get x squared for f. Our outermost terms of the whole expression are x and h, so we get hx for O. Innermost terms are also h and x, so we get hx for I. And lastly, multiplying the last terms in each binomial, h and h, we get h squared for L. Combining like terms, we get x squared plus 2hx plus h squared. By now, I'm pretty confident you should be able to get a hang of the FOIL method. For practice, you can always pause and do the following examples. The answers are in red. As always, thanks for watching.